All right, so here I'm going to go over some explanations for different problems for your Chapter 8 study guide. These are the ones that I thought were maybe a little more difficult, or I just wanted to point something out about them. So if you look at part 1, I'm going to be going over questions 6, 7, and 8. If you look at part 2, I'm going to be going over questions 3, 4, 7, 8, and 9. So I'm going to move pretty quickly. These are just explanations on how to solve them. So for starters, one of the most important things that you should have for your study guide when you're taking your test are you're going to want the formulas of a cylinder, a cone, and a sphere. And then you're going to want the different volume formulas for similar solids. So when you're dealing with similar solids, remember that you would take the volume over the other volume and set it equal to the height of this one's volume over the other height, make a proportion, cubed. And this one for surface area, you have surface area A over surface area B, height of A over height of B, square it. So these are important as well. So let's go over number 6. So number 6, you're given that the volume of this cone is 85 yards cubed. You're going to find the radius. So you don't know the radius, but you know the volume. So let's start with what we know. We know it's a cone, and so my volume is going to equal 1/3 of pi r squared times the height. And I like to rewrite this as basically pi times my radius squared times height all over 3. This is the same thing as multiplying by 1/3. So then I plug in what I know. So my volume is actually, I'm given this, my volume is 85. So 85 is equal to, pi times my radius is, I don't know. So I leave it as r, and then I plug in my height is 9. And then I solve from here. So to simplify this, what I can do is rewrite this. So I know 9 times pi. So I can say 9 pi over 3. But again, I have my r squared is equal to 85. Sorry, it cut out. But basically I have, so 85 is equal to 9 times pi times r squared, all divided by 3. I can simplify. 9 divided by 3 is 3, so I'm left with just 3 pi r squared. And now from here I want to get r alone, so I can divide each side by 3 pi, divide each side by 3 pi, and this will cancel out, so I'm left with 85 over 3 pi is equal to r squared. Now this is where it actually gets a little weird, is I want to get r alone, and right now r is being squared, so again, to undo that, I can take the square root of r, but that means I have to take the square root of this side. So this square root will cancel out this, and then this, I can actually just leave this as my answer and say that the square root of 85 over 3 pi is equal to r. So it's actually as simple as that. I know it might be weird for you guys, but you can actually leave your answer like this. And if you were to solve this, you can totally do 85 divided by whatever 3 times pi is and square it, and your r would be about 3 yards. So either of these answers is acceptable. I know it's funny to leave it in a square root and with pi, but technically as you move forward, this will become a lot more normal to see things like this. So let's go ahead and move on to number 7. So you should have your study guide out in front of you. I'm going to be reading off the question because it was sort of long. But basically for number 7, it says a cylindrical tank can hold 200, so you're thinking of a cylindrical tank, and it can hold 2,279.64 cubic feet of water. Cubic feet means feet cubed, and since I have this, it's talking about a cylinder. I know that this is talking about, this is the volume of my cylinder, And so if I wanted to look here, it says the radius of the tank is 11 feet. So my radius is equal to 11 feet. What is the height? So the height is what I am solving for. So for number 7, I'm going to plug in what I have. I'm talking about a cylinder. So a cylinder is the volume equals pi r squared times my height. And now I plug in what I know. So I have my volume is 2279.64, which is equal to pi times my radius is 11, but I'm going to be squaring it, so let's save ourselves times. 11 squared is 121 times my height. I don't know. I want to get height alone, so I can divide. I'm just going to put this as 121 pi, so then divide this side as 121 pi, and that's really going to be my answer. Oops. Because this is going to cancel out, so I'm left with h equals this. H equals this. So you can actually leave this as your answer as 2279.64 over 121 pi, or you can actually solve it and h would be about 6 feet. So you'll see, as you move forward, either one of these is an acceptable answer, so you'll just have to get sort of used to that. All right, let's move on and do number 8. Okay, so number 8, where's number 8? Okay, so you are given number 8, you are given a cylinder, and it looks something like this, and it has a height of 4 millimeters and a radius of 3 millimeters. And it basically says if you double both of the dimensions, what is going to happen to the volume? So the first thing you'll want to do is, well, I want to find the volume of my original. And then I'll want to find the volume of the one that's doubled. And I want to compare. It asks you how many times greater is the volume of the new cylinder than the volume of the original cylinder. So the original volume, this, is going to be, it's a cylinder, so my volume will equal pi r squared times the height. So that means the volume will equal pi times 3 squared times 4, which is the same thing as my volume is equal to 36 pi. And so I'm going to leave it at there. So the original volume of this is 36 pi. Now if I double each dimension, well, I'm still dealing with a cylinder, so pi r squared times the height. But now watch what happens. If I double pi times my radius is 3. If I double that, my radius will become 6. And then my height, if I double 4, that becomes 8. So now let's see what our new volume is. My volume is going to become 288 pi. So now I want to compare. I found this is the original, this is the doubled volume. So how many times greater is 288 than 36? One way of doing that is I can see, okay, I can start listing out my factors and say, okay, 36, if I double 36, it's 72. Again, my goal is I want to see how many times greater is 288 going to be. So I can see 36, 72, 108, 144. Well, I know that 144 is half of 288. So if this is 72 is twice as big, this is 3 times as big, this is 4 times as big. If I double this to get 288, I have to double this, so I get times 8. So my answer for number 8 is 8 times greater. 8 times greater. Another way of doing this is you can also just divide 288 divided by 36, and that equals 8. So 36 times 8 is going to be that. Either way, 2 different options of solving it. All right, so let's move on. Go ahead. That was all from part 1. So now we're going to head into part 2. And this is number 3 for part 2. Number 3 for part 2. So number 3 for part 2, you are given, this is moving into spheres. So my volume of a sphere is going to be 4/3 pi r cubed. And as long as you know that formula, you should be good to go. So number 3, it gives you the volume and it wants you to find the radius. So the radius of the sphere with the given volume. So I know that this is my volume. Now it gives you a volume. It says that your volume is equal to 36 pi. And so that's equal to 4/3 pi times whatever the radius is cubed. So this is where we will start. Now it looks kind of funky. So this is something that's super important for this problem. You have a pi on both sides. Technically, I can get rid of my pi. If I divide a pi out, that means I have to divide a pi out on this side. Basically, 2 terms that are doing the same thing, they're both being multiplied. These actually cancel out. Since there's a pi being multiplied on this side, you can multiply the pi on, and a pi being multiplied on this side, you can divide each of them out, and that creates an equivalent equation. So now I have 36 is equal to 4/3 r cubed. So I want to get r alone, and there's a 4/3 being multiplied to it, so I can multiply 4/3 by its reciprocal, because that is going to then cancel itself out. But what I do to this side, I must do to this side, so then I'm going to multiply this side by 3/4 and solve from there. So this cancels out, I'm left with r cubed, and then 3 times 36, and then I'm going to divide that by 4. That's going to equal 27. Oops. So then, oh my goodness. Okay. 27 is equal to r cubed. Now to get rid of this cube, to get r alone, I can take the cubed root. So I cube root this. What I do to this side, I must do to this side. Take the cube root. So this will cancel out. I'm left with r, yay, and the cube root of 27 is 3. So my answer is r equals 3. And then number 4 we can go over. So very similar. Again, I'm dealing with a sphere, so my volume equals 4/3 pi r cubed. I know my volume is 9/16 pi. So that will be equal to 4/3 pi r cubed. I want to get r alone. Hopefully you can see this. Sorry if it's a little crooked. I want to get r alone, and so here, again, these pi's are actually going to cancel out since there's one on each side, so I'm left with this. I want to get rid of now 4/3, so I multiply by my reciprocal, because 12/12 is 1, that cancels out. And then I do the same thing on this side. And remember, when I'm multiplying with fractions, I multiply the numerator across and then the denominator across. So 3 times 9 is 27 over 4 times 16 is 64. This will equal, I'm left with r cubed. Again, I want to take this cubed root of each side. And so this is a little throwback. I know that these will cancel out, so r will equal. Now, this basically, when I have a fraction being cubed root, this is the same thing, remember, as what is the cube root of 27 over the cube root of 64. The cube root of 27 is 3. The cube root of 64 is 4. So r is equal to 3/4. So that was number 4. All right, and then we have a couple more. Let's go over 7 and 8. For 7, I want to point out something very important. So if you're looking at all of the ratios for number 7, basically I'm going to write this, can do your ratio in many different ways. You just have to be consistent with which measurements you are comparing. So for instance, if you have two different things, you can do the radius of A over the radius of B, which will equal the height of A over the height of B. You could do, just looking at A, the radius over H, which will equal the other shape's radius over H. You can also do your height over the other height and set that equal to the radius over the other radius. So as long as you're staying consistent, for example, this yellow will represent the same shape. This yellow represents the same shape. So just be consistent all the way through. Sometimes I like to use colors. That kind of helps me. So again, the radius and height, this is one shape, and then the height and the radius of your one shape. So what I did for number 17 is I basically just did 16 over pi. Sorry, this is number 7. 16 over r, which was equal to 20 over 25. And again, you could have done it as 16 over 20 is equal to b. This was labeled as b, actually, so I guess b and r are the same thing in this problem, as b over 25. Do you see how these are all the same ratio? 20 over 25, which is equal to 16 over r. These are all essentially the same ratio. So once you do your cross multiplication with all of these, you'll get b times 20. So 20b is equal to 25 times 16, which is 400. Divide both sides by 20, and you get that b is equal to 20 meters. So that is your answer for number 7. Number 8 is special because you have to use that the surface area over surface area is equal to h over h squared. And so just make sure that if this is the surface area of my first one, my first shape, then this is the height of my first shape over the surface area of my second shape over the surface area, or over the height of my second shape. And so now it's really just plugging in and chugging along. So the surface area of your first shape was, it gives you 1,240 over, you don't know that second surface area. Set that equal to the proportional heights, so 14 over 7 squared. Now because of PEMDAS, I do what's inside of my parentheses first. 14 divided by 7 is 2, so 2 squared is 4. And then I carry down what I have here. Again, just to reiterate, 14 divided by 7 is 2, so then I get 2 squared. That's where that 4 comes from. And then here I want to solve, there's a lot of different ways of thinking about this. You can think of it as 4 over 1 and do cross multiplication. You can also times both sides by x. So if I multiply each side by x, well, this will cancel out. I'm left with 1,240 is equal to 4 times x. I can divide each side by 4, divide each side by 4, and my answer, x is equal to 310 feet squared. So that is your missing surface area for number 8. All right, I know this is a lot. We have one more. So here is number 9. So number 9 is talking about a shape. Basically, if you look at the shape for number 9, it's a cylinder and a cone. So you want to add, your answer is going to be the cylinder added to the cone. The volume of a cylinder is pi r squared times the height, plus the volume of a cone, which is 1/3 pi r squared times the height. So now I just plug everything in. So that's going to be pi times my radius of my cylinder is 4, my height is 40. And I want to solve that separately and add that to pi times my radius, which is 4 squared, and then my height is 12. Divide that all by 3 because it's a cone. And basically you solve from here. And if you solve all of this out, you get that this is equal to 640 pi plus, this is 192 divided by 3, sorry, 192 pi. So 192 divided by 3 is 64, but that's 64 pi. And then if you add those together, that becomes your answer of 704 pi, which is about 2,211. So either of these could be your answer, but this is your, and I think it's cubed. So this is going to be your volume of that shape that has two different shapes attached to it. So I hope that helps. That just kind of takes you through some of those more difficult problems. Let me know if you have any questions, and keep it up.